Our next speaker is Helge Hjernen from InCoax. He is calling in from the Nordics. He will address the architectures after the fiber demarcation point. Helge is head of product management, sales and marketing at InCoax, and the title of his presentation is Fiber to the Economical Point. Sorry. With that, it's all yours, Helge.
Thank you, Bernd, and thank you, team, for arranging this. I will go into what is the challenges around an MDU, MTU, multi-dwelling unit, multi-tenant unit of the brownfield areas. And this is testified by the number of operators. If you take the next slide, please. This is what we hear both in Europe and US, that there is a number of challenges when you want to deploy fiber to the home in these type of complexes. They are, in principle, looking a little bit different, but they have the same principle that there are many tenants or many persons living in these units. The first question we will address, who is investing into the in-building fiber? Is that the operator or building owner? If you take, for example, Sweden, there has been a trend during the last 20 years that this is a thing which the building owner invests, and they can increase their rent or take out the charge for that. But that's not the case in many other countries. So if the operator takes that, what is the insurances the operator get that this is an usage right for that operator? For example, in France, if you deploy an fiber into a building and you are the incumbent operator, then you have to put the additional free fibers. So in principle, you're building the network also for your competitor. Then there is the next issue, which is what is the minimum take-up rate to justify fiber investments? Is it 15%, 30%, or is it more than 50%? And in many cases, when you deploy a new fiber service, a fiber to the home service, it is very difficult to get people excited to join this new service because they have already a contract with either a mobile operator or a DSL operator. So it's very difficult to get up the investments. And I will show a little bit later in this presentation what that will mean in money. Then, of course, you can also have group subscriptions. That means you make a bulk agreement. So the building owner is signing for these basic services, and the provisioning of additional residential services possible through the operator. But there is one big problem there, is the building owner or the condo association making the decision which operator should serve their tenants or the MDU apartment owners. So it's not so easy. So that point comes always up when you talk about MDUs. How should these services, should it be only from one operator or from several operators? Then comes a number of regulatory requirements. One is, as I mentioned earlier, must operator install fiber to its competitors? Must there be already still TV services or other services from other vendors? So the regulatory requirements are not so easy to tackle with. And we can see also movements in Europe that the regulators, they want to include all the possible infrastructure to be deregulated. So everyone should be able to use those. And then in the end, it comes the in-building fiber ownership. If an operator invests into this, is the ownership of that fiber belonging to the operator, or is it belonging to the building owner? And when should that transition go over to the building owner, if you agree on that? And is there any exclusive usage rights of that infrastructure? So it lands back on operator or building owner, who is taking the investment. Next, please. If you look on an MDU building, there are a number of, let's say, called hurdles. First, you have to have a consensus on investing in new cabling among the condo owners. And in many cases, maybe the condo owner is not the person who is living in that condo. So what is the interest of the condo owner to get higher speed to its apartment? Then also you need to do an entry contract with the condo association. I mean, you have to have an entry agreement that you are allowed to go into the building, do the construction work, mount a panel or equipment in the building. And then you have to do a wiring construction within the building. Either it's a fiber or data cable to each of the condo units. And when you come inside the condo door, that means you don't reach the heart of the apartment. You maybe need to also do in-wiring in the apartment. And then you have to have an access agreement to each of the condo units. And many people are not so happy to let people in, especially in these COVID times, that you don't want to have foreign people coming into your apartment. So that's stopping up the process also. And then finally, you have to do a subscription contract with each of the condo owners if you don't do a bulk agreement. And that's very difficult, have been testified by a number of operators that do the MDU business. Is not easy. If you can use the existing infrastructure, then you reduce the number of hurdles. Of course, you have to have an entry contract with the condo association. You have to do a subscription contract with the condo owner. But of course, it's much easier. You have only a few parts you need to agree with the apartment owner or the tenants or the condo owners. And that can speed up the deployment. And we see this happening today. I will tell more about that later. If you take the MTU, which is the multi-tenant units, next picture, please. It's not so difficult in this case. I mean, then here you have only an entry contract with the building owner, and you make the agreement with the building owner for wiring the cables, data cables, and so on. And also the access to each of apartments is decided by the building owner. So it's easier, but still there is a number of barriers you have to come over. And one of the larger barriers is the rights to go into private people's homes for a technician. And that usually maybe is not doable in these COVID times, but it's also maybe a problem because it's daytime work time when you do the installations and people are not home at the right time. So again, it's very much easier if you can use the existing wiring in this building. If you take the next one. Therefore, we started in Broadband Forum a couple of years ago a project which was called Fiber Access Extension. And the idea with that was that trying to include all different type of access technologies which can use the existing infrastructure. It was including GFast, G.hn, and MOCA Access. These technologies needed to be described how can I deploy these. And then we created the fiber to the extension point. The reason why it is different from what you use in GFast is that maybe, for example, a Coax loop is not starting on the same space as a telephone wiring. Typically, they are not. And they don't go so far because the TV signal, because these are built for the TV distribution, can't go the same distance as a phone call can go. So we established a number of deployment points. One is the FTTep 02, which is an outdoor cabinet or a pole, which is on a distance typically 200 meters from the building. Or it can be a wall cabinet, which is the EP01. It can be in the basement, or it can be in the loft. And if you go to the right picture here, it's multi-dwelling unit. That can, of course, be, it's the same. You have the FTTep 02, which is an outdoor cabinet. It can be a garden cabinet. And again, typical distance 200 meters from the building. But then you also add in an MDU that you can have the extension point on each floor, which of course then depending on the infrastructure, if it's a point-to-point infrastructure, if it's a point-to-multipoint infrastructure, you can reach each of these apartment units. And both of these cases are showing that you don't need to go into the apartment. You can do all the construction work during daytime. You can install the fiber into the building, and then you can activate the service, and then the NTEs, the modems, they are self-installable by the customer. So this is the reason that we wanted to include more of the technologies to FTTep. If you take the next one. And of course, there is two ways of using. There is the telephone wire and there is the coax network. And coax network is not so much used today. It's more the twisted pair because of the traditions from the telecom industry. But with the changes which is happening in the TV distribution, pay TV side, for example, in US, 2014, there was 100 million subscribers on pay TV. Today, there is only 70 million left. The number of satellite companies are getting their services closed down because you have all these services over the internet. So there is an infrastructure opening up which you could use, but it's not known, and people are not, operators and vendors are not known that we can use that technology for providing up to 10 gigabit speed. And this is something which the twisted pairs will not be able to support. So I will show you one technology area which is possible to use in this. If you take the next one. One of the technologies are MOCA Access or MOCA technology. It was started in 2005 as a home network technology to be used in private homes. And it has evolved during the time, first from being in a home networking technology, and by 2017, we finalized the MOCA Access specification, which is a point-to-multipoint technology for the home networking. Of course, is a mesh-based technology, so that is, they can't separate the customers. But in the MOCA Access, we can separate the customers. And we started also the work with MOCA 3.0 for the home networking side, and there is a specification ready for that. We have added to the MOCA, both of them home networking and access technology, security layer. And now we are in the phase of starting up the MOCA Access 3.0 work, which is providing 10 gigabit to each individual subscriber, and that is 10 gigabit symmetrical services. So you can use the coax network for very high speeds. I mean, the speed in principle what fiber provides today, it is possible to use the coax networks. If you take the next one, MOCA technology of today can provide max speed of 2.5 gigabit download and 2 gigabit upload. It has an enhanced mode which can provide 3.2 gig. So in principle, if you have a point-to-point connection, you can provide a 2.5 gig down and up speed for each subscriber, which is, I would say, the latest level, which is, for example, in US, some operators are already introducing 2 gig. So MOCA is very well adapted for these very high speeds, which are possible to provide if you have a 10 gig, either an active Ethernet or an XGS-PON northbound connection. And of course, this MOCA Access technology is configurable, so you can have a symmetrical upstream and downstream, and you can also have a different profile. So if you don't have so much available spectrum in the coax network, you can run lower speeds. And that is especially if there is, for example, TV services which the MDU owner or the MTU owner want to keep. And it has a very low round trip latency of less than 6 milliseconds. And if you run it point to point, then it's even lower. And we are currently working in the MOCA Access group with low latency, ultra low latency, which is less than 1 millisecond. And MOCA Access is using a frequency range from 400 to 1675. So it is designed to be able to coexist with other services like TV services, and even you could have the case where you compete with a cable operator, the DOCSIS 3.1 services, and you can have an additional own broadband service in parallel with that. But that's maybe not so commonly used because you want to take over the full customer. And it is a point-to-point connection. Point-to-point connection can provide 2.5 gig to the subscriber. A point-to-multipoint can provide a gigabit symmetrical to the subscriber. And it supports also multicast of a coax link, and it has a number of power controllers to extend the reach for each one. So MOCA Access technology is really made for fiber access extension deployments. And it is already today available for multi-gigabit. If you take the next one, please. Here are a little bit of the bands. There is 5 MOCA Access frequency band, and the reason for this is that if you want to have coexisting services, for example, must carrier TV, which are a legal requirement in some countries, then you have to be able to set the MOCA bands on places which are available in the coax structure or coax network. If we go to next. Wrong way. A little bit of what is FTTep. It's a point-to-multipoint gigabit service and fiber access extension. I would like to a little bit more technically explain that. It is consisting of a DPU unit. In this case, it's a MOCA Access DPU unit. It has an ONU, and it can be a gigabit ONU or it can be a 10 gigabit ONU. And then it has a MOCA network controller unit, which in this case use a splitter to split up it for each of the customers, and you can have up to 31 clients behind. But that is of course not a good gigabit design, because if you want to have a 1 gigabit symmetrical, then you maybe shouldn't have more than 8 to 15 or 16 subscribers sharing that, depending on what your overbooking rules are. But it can provide a symmetric gigabit speed. It means that to each of the modem you have a gigabit out, but on the coax link you have 2.5 gig. So it is some overbooking you do in this case, but still you can provide symmetrical gigabit. And this is a very popular model for garden type of MDUs, smaller MDUs. We can see interest both in southern part of Europe, where there's a lot of small MDUs, but also parts of US where you have small MDUs, but you cannot reach this with fiber to the home, or it becomes too expensive. Another approach, if you take the next slide, it is to use this MOCA Access DPU in another way, that you have individual MOCA Access network controllers. So you can have 8 or 16 controllers. That means you have a coax network where you have a point-to-point connectivity. This is very typical in US, that you have point-to-point. But even in Europe, because there are, for example, Germany, it is about 50% of the MDU buildings, they have a point-to-point coax. If you add to that also satellite receiving systems, then you land up at something 70–80% of the buildings have a point-to-point connection. And in this case, you can provide a 2.5 gig up and down link speed to each of the subscribers. So and on the northbound side, you of course have a 10 gig connection. It can be either an XGS-PON or it can be an active Ethernet. Next, please. And if you look on this fiber access, it is the FTTep, the economical point. And the reason why we have given the name economical point is that when you do an SFU installation, a single family unit installation, which is typically a GPON or XGS-PON, and of course that is terminated in an ONT, and then you probably have your own Wi-Fi network, but you don't need any additional equipment. But as soon as you go to a small MDU, then it becomes more expensive to install the fiber to each of the apartments. And keeping in mind, if you have a 15% take-up rate, it is a very costly investment, because you only get, for example, in a building with 10 or 30 subscribers, maybe get 3 customers from the beginning. So it doesn't justify the investment. And the interesting is that as bigger the MDU becomes, and you have still very low take-up rates, 15 or 30%, it is very much more costly to do an investment in the fiber to the home installation of new wiring compared to using the existing infrastructure. And this is now for the gigabit service, so symmetrically 1 gig up and down. If you take the next slide, If you go for multi-gigabit, in that case, it was the MOCA Access DPU having individual ports to each of the subscriber. Of course, the cost of the FTTep goes up, but still it is much more affordable, also for smaller MDU, and especially for the larger MDUs if you have a low take-up rate. So this is the reason why we call this FTTep, not extension point, but we also call it fiber to the most economical point. And what is the difference using the Coax in the building? In principle, there is no difference to use the Coax compared to FTTH. Of course, you have to have chip technology supporting that you transmit this over radio. But anyway, in the endpoint, you will always have a copper port, for example, RG45 port, and then it's depending on what your equipment is capable of handling in that side. And today it is typical 1 gigabit ports on each of the devices you use, I mean PCs and laptops and so on. And in the future, we will see that will increase. And of course, then this type of technology as MOCA Access will also evolve. So it is not odd to use the Coax. It is more natural when you look on it from this point of view. If you take the next one. Products, they are very tiny, small. This is a little bit advertising. This is a fiber to the extension point fiber LAN solution. It has a 10 gig active Ethernet port out, and there is 4 individual ports out. So this is one form factor. So it's not a huge equipment. It is a very tiny, small, low power consuming. If you take the next one. Of course, the next step is to do this also with for PON and XGS PON. And of course, that will be based on the TR301, which is the baseline for FTT for the TR419. TR301 is the way how you communicate with a GFAS node in a PON network, and it supports, of course, the netconf young. You have a number of adoptions to existing management tools. And that is, it's not yet released from us, but we are working on that for during this year. We will have a release on the PON generation. Thank you. So fiber to the economical point means use the existing infrastructure. Coax can provide multi-gigabit. Thank you.
Thanks a lot, Helge. I like that last slide, the future PON product.